Alright everybody, good to see you. Let's do this now. We'll take a look at these practice problems here. So we have a circle here with this equation. It's going to be reflective of a line y equals 1. Alright, so I've gone ahead and sketched this here. Note that a circle here, the only really important parts about the circle, what defines a circle, is a center and its radius. So we have the point 4, negative 1, and its radius is going to be radical 8 here. So that means our circle is going to look something like this here, if I were to sketch it approximately. And again, this is a really awful sketch, but you get the picture here. Now, noting that we're reflecting the entire circle here, first off, we know that these 2 points are going to remain the same because they're on the mirror line here. But the nice part about this is that if you think about what's going on here, if you reflect the circle over this line, it's not going to distort it. So that means we know that this radius of the circle is going to be the same as the radius of this one here. The only difference is the location of its center, right? This point, this center here, it makes sense that it's going to be reflected somewhere up here. So that means we can figure out what this distance is here, and then we can go up that way and figure out where it's going to be. So it's going to reflect its way up here some distance, right? Now we know this distance is 2, so that means this distance is also 2 as well, which means that this is going to be the point 4, 3 here, and that's going to be our new circle. And indeed, if we were to draw this, our new circle is going to look something like this here. Okay? Our circle is going to be something like that. And again, I apologize for the really awful picture here. But this new circle is going to be the image of the old circle after our reflection here. Actually, maybe I should just do something like this here, make it a little clearer. So we can see that this is going to be the center, is going to be at the point 4, 3, and the radius is also radical 8. Okay, so that's going to be the important thing here, and now we can actually put it all together. So according to our equation of the center, the equation of the circle, we have x minus 4 squared plus y minus 3 squared equals 8, right? Because the radius squared is 8. Now note that it's going to be with this equation here, so we're going to have to unpack everything. We get x squared minus 8x plus 16. This is going to be y squared minus 6y plus 9. And that's going to be equal to 8 here. So let's go ahead and regather everything in this proper form here. We get x squared plus y squared. There's going to be a minus 8x, a minus 6y, and then what appears to be a 25. And then we have to subtract 8 from both sides. So 16 and 9 is 25. We have to subtract 8 from both sides. So we get x squared plus y squared minus 8x minus 6y plus 17 equals 0 here. So now it's pretty clear what the numbers are. A, B, and C. A is negative 8, B is negative 6, and C is 17. So we get negative 8 plus a negative 6 plus 17. Now negative 8 and negative 6 is negative 14. We add 17 to that. That's 17 minus 14, which should give us 3. Okay? Now, let's look at number 4. So number 4 here, we have a segment reflected over line y equals x, and we're going to let this image be a prime, b prime. What relationship exists between the slopes? Okay, so let's go ahead here. So here's a, and here's b here. We're just going to sketch these out like that. Now, I'm going to call this p, q, and I'm going to call b, r, s, since I don't know where they are. Now, we know that when we're reflecting over the line y equals x, that just simply switches the coordinates here. So that means we're going to end up with something that looks like this here. So b prime is going to be the point s, r, right? And a prime is going to be somewhere over here, and that's going to be a prime is going to be q, p here, right? So we have something that looks like that. Oops, sorry about that. So now we can calculate the slopes of these things here. So the slope of AB here is going to be S minus Q over R minus P here. Okay. And we have the slope of A prime B prime, and that's going to be equal to R minus P. So R minus P, the Y coordinates, the X coordinates are S minus Q. Now, if you were looking carefully and see what's going on here, wait a minute, you notice something important here. These are reciprocals. So note that the key here, that this is true, right? So the relationship exists. So the key here is that the slopes are indeed, note that they're regular reciprocals. Note they're not negative reciprocals because we don't have any minus signs here in front, but we have these here, S over Q and S over Q here, R over P and R over P here. So we can say that the slopes are reciprocals of each other. The product is positive 1. Okay. Alrighty, now let's look at number 5, the last one here. So we're going to determine the image of the point 3, negative 2 under the translation reflection over line M, where M is this line here. Now, you may recall this is actually very similar to what we looked at in part 2 of the lecture notes here. So we're going to go ahead and sketch this out and see what happens. This line y equals 1/2 x plus 3/2 is going to go something like this here. So I'm going to just go ahead and sketch that line like so. This is going to be our black line like so, like this, okay? There we are. And this is, so we know that this is m. This is have a slope of 1/2 and passes to the point 0,32. So I'm going to go ahead and label that here. We have our point 3, -2. It's going to be somewhere around here. So here's 3, -2. I'm going to call this point here K. Now we know that its reflection is going to be somewhere over here. So basically we want this here, right? If you remember, we wanted this here. Here's going to be K prime. And I'm going to call this here, we're going to call this here A and B, since we don't know where that is. Remember that we want, right, the idea is that we want KK prime to be perpendicular to M. And this point here, C, I'm going to call it C, we want C to be the midpoint of KK prime. Okay? So again, we're going to break this down into several pieces here. We're going to try to figure this out and see what this is. I'm going to call this C, D here. So we're now going to figure out what's going to happen here. The nice part about this is that we know that the slope is 1/2 here. So we know we can determine here, therefore, that the slope of M is 1/2. So the slope of, in this case, let's go ahead and write this out here. The slope in this case of KK prime is going to be -1 divided by 1/2, which is in this case -2. That's pretty straightforward. So now we know it also passes to the point 3, -2 here. So therefore we can find the equation of the line. So the equation, so KK prime here, we're going to write the equation of that line using this point slope form. That's going to be y minus a -2 equals -2 times x minus 3, right? So this becomes y plus 2 equals -2x plus 6 here. Pretty straightforward. So we get y equals -2x plus 4 here. Now that means this equation here, this line has equation y equals -2x plus 4. So we want to determine point C, and luckily it's intersection of this and line M, so now we can set them equal. We can now solve. So now we know that this is going to be true here. We also have the original equation y equals 1/2 x plus 3/2 here, so now we can set them equal to each other, right? So let's go ahead and solve this. We can now write this out here. So therefore we get -2x plus 4 equals 1/2 x plus 3/2 here. I'll multiply everything by 2 to clear all the fractions. We get -4x plus 8 equals x plus 3 here. So it looks like -5x equals -5. So that implies that x is +1 here. That's actually quite nice. So that means we know that this point is going to be 1 comma something. And now we can also go back and solve for y here, since we can use whatever equation we want. We know y equals -2 times 1 plus 4, so it's going to be -2 plus 4 here, which is +2. So that actually tells us something important here, that the location of C is 1, 2 here. So now in order to figure out K prime, we just need to we can now use the second half here, that C is the midpoint of KK prime. So therefore we now know that 1 is going to be 3 plus A over 2. And we also know that 2 is going to be equal to b plus -2 over 2. So we can solve these equations separately. We get 2 equals 3 plus a, so a is -1 here. And then we get 4 equals b minus 2, so b equals 6 here. Therefore, this is going to be K prime is going to be the image, and it's going to be at the point -1, 6 here.